Hi, I'm Andrew, and I'm going to tell you about our work, Can Language Models Learn from Explanations in Context? In this work, we took inspiration from human learning, and in particular, the pedagogical aspects of it. Because in human learning, we often get not just the correct answer to a question, but an explanation of why that answer is correct. And explanations are powerful because what they do is they link between a particular question and the more abstract, generalizable principle that underlies it or the task that's being performed. So this leads to the natural question, well, why doesn't anybody explain things to language models? So in this work, we wanted to explore whether giving explanations to language models could improve their few-shot performance. Few-shot prompting is a fairly standard paradigm for large language models now, where you give examples of a question of the kind you want the model to answer and the type of answer that you would like it to give. And it's been shown that this method can improve task performance with no training needed. You can also do things like adding instructions to the prompt, either zero shot or before a few shot prompt. But what we wanted to explore in this work was whether giving explanations of each question after the answer could help the model to perform the task better by identifying the principle by which the questions are answered. So we explored this question on a bunch of tasks taken from the Big Bench Challenge, including things like reasoning about steps of a process, or evaluating what information you would need to answer a question, or identifying metaphors, or answering riddles, or solving mathematical induction problems. And these tasks are diverse and involve various kinds of reasoning. For each of these tasks, we hand annotated them. We annotated 3 5-shot prompts from each with explanations. So that gives us a total of 15 annotated task examples. And we also annotated each task with 3 possible instructions. And to make sure we were doing careful evaluation, we implemented a lot of careful methods and controls. So there's a lot of issues with prompting LMs few or zero shot, but secretly tuning these prompts during the process of developing the work. So in this work, we were fairly careful to evaluate totally untuned explanations as written originally, as well as 2 separate tuning conditions. And we compared to a variety of control conditions that measure whether the effects we observe are due to lower level features of the language. For example, providing the model with a true but non-explanatory fact about this question as an explanation, or an explanation of a different example that comes from the same prompt, or the original explanation with word order scrambled. And we also measure control non-instructions, such as these are the correct answers to the final exam question. And as I mentioned on the previous slide, we considered also selecting or tuning explanations. So we did this in 2 ways. So one way is to select the examples and explanations that build up a prompt. We have 15 examples annotated, but we only used up to 5-shot prompts. So we can greedily build a 5-shot prompt by seeing how well the examples used predict the other 10 examples that we annotated. And we can either do this with examples that have explanations in them, or just as examples that as a control without explanations, or examples with control explanations. And the second kind of tuning we considered is to hand tune explanations on a few of the most challenging tasks. So what that means is that we actually went in and edited the text of the explanations and tried to improve the performance on the other 10 examples, again, that we'd annotated as a validation set. And in both cases, we test performance on the remainder of the data set. We analyze the data from these experiments with hierarchically structured analyses that respect the data structure. So we have a large data set of 40 tests from Big Bench, various language models, various types of prompting conditions, instructions, controls, explanations or controls, and so on. And so we took inspiration from behavioral science to analyze this using the methods that behavioral scientists use. In particular, a hierarchical logistic regression that accounts for all of this nested structure of the task. So I'm not going to describe this in full detail, but among other things, our model accounts for things like the idea that the effects of examples, explanations, and instructions might differ by task, either because of the task difficulty or because the examples and instructions just aren't as good for some tasks. It could be that different prompts we create for the same task might have different benefits because of variability in the examples or the way we explain things. And it could be that different questions for a given task might have different difficulties. And our model takes all of this into account when assessing the effects of our different interventions. I'm going to show you a quick summary of the results, and you can check out the paper for more. So in this summary, I'm showing you the change in performance estimated by this hierarchical logistic regression model from different things that you could add to the prompt. So for example, on the left here, you can see the effect of adding few shot examples to a prompt rather than doing a task zero shot, aggregated across other conditions like whether or not you have instructions and so on, but not including explanations. And what you can see is that there's a fairly large effect of adding few shot examples to the prompt. It improves performance substantially, as has been shown in prior work. Now, in the case of untuned explanations and controls for those explanations, what we find is that untuned explanations have a significant effect of improving performance on the task, but it's smaller than the effect of the examples themselves, about a quarter the size. By contrast, however, control explanations do not have any effect. So it really is something about the explanatory nature of the statement. Even giving the same explanations in the prompt but applied to the wrong questions does not improve performance. Now, the effects of the tuned or selected explanations can be substantially larger. Again, for the hand-tuned explanations, we only considered a subset of the tasks, but there we observed a very large effect across those tasks. Selected examples and explanations have a significant effect, and it's much larger effect than just selecting the examples or selecting the examples together with control non-explanations. And finally, we looked at instructions, and concurrent with some other work that's shown similar things, we found that the effect of instructions on these tasks was very minimal compared to the effect of few-shot examples or even of explanations. Now, there's a lot more analyses in the paper, including breakdowns by tasks and task clusters, looking at how performance affects these things, how they interact with instructions, looking at distributions of effects and the full model results, and so on. I'm not going to tell you about all of that today, but I encourage you to check out the paper if you're interested. And of course, in the paper, the other thing we do is discuss the lots of related work that has gone on in this area before our work and concurrently with our work. And so I'd encourage you to check that out if you're interested in our thoughts. So with that, I'd like to thank you for listening to this talk. I hope you'll check out the paper, and I'd like to thank all of my co-authors and collaborators for all their help on this project. Thanks.